Have you ever just stopped and wondered how an AI can take a simple phrase, just a few words, and turn it into a work of art? Well, in this explainer, we're going to pull back that curtain, and let me tell you, the secret is probably not what you're thinking.
I mean, we've all seen it, right? These mind-blowing results from tools like Sora, Luma, and DALL-E. You type in a few words, hit enter, and out pops this photorealistic image, or even a stunning video clip. It seriously feels like magic. But what's really happening under the hood? How does a machine translate a simple idea like, say, a dog on a skateboard into a detailed picture with shading and perspective? It seems impossible, and that's exactly the question we're going to answer. And the answer is just fascinating because these models don't build an image from scratch, not really. Instead, they find it by first learning how to perfectly destroy something else. Yeah, you heard that right. Creation through destruction.
Here's a great way to think about it. The whole process is kind of like watching a movie scene in reverse. First, the AI learns how to take a perfectly clear image and just turn it into dust, pure chaos. Then, when it's time to create something, it learns how to pull all that dust back together into something completely new.
So this whole idea of noise and denoise isn't just some loose concept. It's a formal, three-step method that is at the absolute core of how these incredible AI tools actually work.
And it all boils down to this really elegant three-step cycle. First, you add noise to systematically destroy an image. Next, you train the AI to become an expert at recognizing that specific pattern of destruction. And then, for the final creative step, you use that expertise to reverse the whole process, building a brand new image right out of the chaos.
Okay, so it's super important to remember that this whole thing begins with the very thing we want to create: high-quality data. The training starts with a massive library of thousands, sometimes millions, of crystal-clear images. And this is the destruction phase. Over hundreds or maybe even thousands of tiny steps, we layer on what's called Gaussian noise. And it looks just like old TV static, until the original picture is completely lost in this sea of random pixels. Now, what's so surprising here is that this first step has absolutely nothing to do with machine learning. It's just a fixed, predictable mathematical formula. We know exactly how much noise gets added at every single step. And that precision, well, that's the key to everything that comes next. Okay, so now the AI finally comes into play. We show it all those noisy images from our data set, and its only goal is to guess the exact pattern of static that was added to get it to that state. It's not trying to see the original image underneath, just the noise itself. So this is where the learning really happens. The model makes a guess about the noise, and then we show it the actual noise that we added. It sees the difference, adjusts its thinking, and tries again, millions and millions of times, until it becomes an absolute expert at spotting the exact pattern of static at any stage of the process. And this is where the creation begins. The model doesn't start with a blank canvas. No, it starts from a canvas that is already filled with pure, random static, just like the noisiest images it was trained on. So now, it just applies its training, but in reverse. It looks at this noisy image, it predicts the pattern of static within it, and it simply subtracts that static. It does this over and over again, and with each step, a clear, coherent image starts to emerge from the randomness. It's like a sculptor chipping away at a block of marble. So this whole noise and denoise method is obviously super powerful for images. But what's fascinating is how this exact same core idea can be adapted to create totally different things, like audio and video. The core idea translates pretty directly. For audio, you just use white noise instead of TV static. But for video, things get a whole lot more complex. You're not just denoising one image, you're denoising a sequence of them, and they all have to make sense together. And this right here is the major hurdle for AI video. It's not enough to create one believable frame. That frame has to connect perfectly with the one before it and the one after it. A car can't just appear out of nowhere. It has to move smoothly and look like the same car from one moment to the next. That's consistency. Okay, so we've covered this whole noise and denoise process. Now we can get to the final piece of the puzzle. How does your text prompt actually control this whole thing? Well, this is where the text prompt finally comes in. A language model reads your words, like a cute cat, and converts that idea into a unique set of numbers. It's kind of like a mathematical fingerprint for your idea. And that fingerprint acts as a compass for the denoising process, guiding it at every single step to make sure the final image that emerges from the static is, in fact, a cute cat.
All right, let's zoom out for a second and just summarize the entire really elegant process we've just uncovered. And here it is, the complete blueprint. It's a beautiful cycle when you think about it. You don't teach an AI to paint, you teach it to recognize chaos so perfectly that it can then reverse that process, carving order out of pure randomness, guided only by the ghost of an idea from your text prompt.
What's just so mind-bending about all this is that AI creation doesn't start from a blank canvas. It starts from a canvas that's already completely full of chaos. And the art is literally found by carefully removing the noise until a clear signal emerges. So, knowing that every single one of these stunning AI creations begins its life as a field of random static, we're left with one final question. Does understanding the method make the result less magical, or does it reveal a deeper, more elegant kind of magic altogether?